This video is going to cover how to do hypothesis testing for a population mean using a TI-84. I have here on this screen the 5 steps that you need to complete to be able to do population mean hypothesis testing. The very first thing you should always do is state your null and alternative hypotheses, and you should also always state the claim. Make sure you know which one is the claim. Then number 2, the step 2, you need to determine which of the 2 tests you need to use. Now when it comes to testing for a population mean, there are 2 tests. There's a z-test and the t-test, and this flow chart discusses how to determine which one. We'll go through that with the examples. Then after you've performed the correct test, you want to find the p-value. That's step 3. Step 4 says compare your p-value to the alpha in the problem, and then you will determine how you word your final answer based on what your claim was and whether you rejected or failed to reject HO based on your p-value. So we'll cover some of these. We'll cover this in the examples below. So the monthly apartment rent in the city of Minneapolis is reported to be normally distributed with a mean of $1,005 per month. You collect a random sample of 15 apartments and find the mean rent to be $1,100 with a standard deviation of $55. Is there enough evidence to reject the claim at alpha at 0.05? Okay, so the first thing I need to do is state my null and alternative hypotheses. So the hypothesis is that the mean is $1,005 a month. So now you need to figure out, does that represent, I couldn't find my cursor for a minute, does that represent the null or the alternative? So it says the mean is, or a mean of $1,005. So that means it is saying that the mean is equal to. So notice here, the null and alternative hypotheses are the exact opposite of each other. And also notice that the null hypotheses always have an equal to symbol. So it could be equal to, greater than or equal to, or less than or equal to. And as I said, the alternative hypotheses are always the opposite. So if it's equal to, you use not equal to symbol. If it's greater than, you use less than. If it's less than, you use greater than. Okay? So in this case, it's saying that the mean is equal to $1,005 a month. So that means my claim is the null hypothesis. So I'm going to start by saying, whoa, my handwriting looks really bad. Let me try that again here. HO, so mu is equal to 1,005. Sorry, I got a new tablet and it looks pretty bad. Okay, now I want you to state my alternative hypothesis. So my alternative hypothesis will be the opposite of that. So since this one was equal to $1,005, this one will be not equal to $1,005. And my handwriting looks really bad, I'm sorry. Okay. So the next thing I need to do is figure out which of the tests I'm going to use, the z-test or t-test. So let's go through and look at my problem and see what information I know. So you randomly collect a sample of 15, so that means n is equal to 15, and find the mean rent to be $1,100. So because this is the mean of the sample, this is the sample mean, or x bar, 110. The standard deviation is equal to 55. Now be careful here, this is the standard deviation of the sample, so it should be little s. Okay, is there enough evidence to reject the claim? I'm going to go ahead and write alpha here, 0.05. Okay, so let's look at this chart here. Is it normally or normal or approximately normal? Let's see, it does say normally distributed, so yes. Do I know sigma? Now sigma is the population standard deviation. It didn't say anything about the population standard deviation in this problem, so it's no. So that means I'm going to use the t-test in the calculator. Okay, so I have all the information I need to be able to perform that. I'm going to hit the stat key and go over to test, and notice the second thing is t-test. Okay. Now, it's going to first ask for input, data, or stats. Data is if you're given a chart. that has all of the information. Stats is if you're essentially given a word problem. In this case, we're going to use stats because we were given a word problem with all of our values here. So I'm going to highlight stats and then press enter. Then I need to go down and it says mu naught. Okay, mu naught is the number that shows up in your null and alternative hypotheses. So 1005. Then x bar is 110. Oops. 1100. Then S is, I keep losing my mouse, sorry. There we go. S is 55 and N is 15. Now the next line is asking you what is your alternative hypothesis. Okay, my alternative hypothesis in this case is not equal to, so I need to make sure that's highlighted and press enter. Then I go down to calculate. Now this works kind of like a button. If you press enter on calculate, it'll calculate everything for you. Now the thing you're interested in is this P right here. Okay, so this is my step 3. P is equal to. Now notice it has E -5. That means that this is written in scientific notation, so you need to move the decimal point 5 units this way. So whatever this number is, if it's a negative, you put 1 less 0 in front, so it'd be 0.1234103. Okay. So now I finished step 3 by finding my P. And so I need to figure out, am I going to reject HO or do I fail to reject HO? Now if P is less than alpha, we reject HO. If P is greater than alpha, we fail to reject HO. The way I always remember these two is if P is less than alpha, it uses the one with less words. If P is greater than alpha, it uses the one with more words or greater words, you might want to say. So in this case, our alpha was 0.05, so P is most definitely less than alpha. So that means I am going to reject HO. So reject HO. Now I just need to figure out, well, what am I going to say about this? Okay, I need to determine how I'm going to word my answer, and that's what this chart here is for. Okay, so I forgot to write what the claim was. The claim in this case was this one, and it's always important to make sure you note which one, HO or HO, is the claim. Otherwise it makes this last part difficult. So HO was the claim, so yes, do we reject HO? We did. So we would say there is enough evidence to reject the claim that. Okay, so there is enough evidence to reject the claim that, and the claim was the mean is $1,005 per month. The mean rent is $1,005 per month. Okay. So when you're looking at this chart, notice that there's really two things that change: the word enough or not enough, reject, and support. Okay. Whenever you have the claim being HO, you're going to talk about rejecting. Whenever the claim is the alternative hypothesis, that's when you talk about supporting. Okay. So let's try the next one. Okay. In an advertisement, a pizza shop claims that its mean delivery time is less than 30 minutes. A random selection of 37 delivery times has a sample mean of 29.5 minutes and a standard deviation of 3.4 minutes. Is there enough evidence to support the claim at alpha equal to 0.01? Okay, let me actually scooch this down a little bit, give myself some more room. So the very first thing you need to do is state your HO and HA. So the pizza shop claims that the mean delivery time is less than 30, so they're saying that mu is less than 30 minutes. Now because this doesn't have an equal to symbol in it, this is definitely HA. And this time I want to make sure I write claim. Okay, then I need to figure out what HO is. HO is always the opposite of HA. So if this inequality symbol is pointing to the left, this one needs to point to the right, and it also has to have an equal sign underneath it. And let me rewrite that claim, because it looks really bad. Sorry, like I said, it's a new tablet and I'm still getting used to it. Okay, so mu is greater than or equal to 30 minutes. Okay? So now we need to figure out which of the tests we're going to use. So I'm just going to write out all the different information in here. A random selection of 37 delivery times, so that means n is equal to 37. Has a sample mean, so x bar, of 29.5 minutes, and a standard deviation of 3.4. And we're looking at an alpha, let me go ahead and write minutes, and alpha at 0.01. Okay. So now what I need to do is figure out which test I'm going to use. Okay, so is it normal or approximately normal? Well, it doesn't appear to say anything about that, so no. Is n greater than or equal to 30? Yes. So since it doesn't say if it's normal or approximately normal, and n is greater than 30 because it's equal to 37, then we're going to use a z-test. Okay, so let me just write here with this one. Let's write here just that we wrote the t-test because that's what we used. This time we're going to use a z-test. Okay, so you go to stat, then over to tests, and the first one is z-test. We're going to highlight stats because we're essentially given a word problem and all of the information is already told to us, like what the mean is and everything. Now under mu naught, we are going to write the number that shows up in our hypotheses, so 30. Sigma, now here's one interesting thing about this problem is we don't know sigma, we were not given it. However, whenever you have n greater than or equal to 30, you can assume that sigma is approximately equal to the standard deviation of the sample. So I'm going to use the sample standard deviation in there, which is 3.4. And I should have that written in here. Yeah, see, use S to approximate sigma if unknown. Okay. X bar was 29.5. N is 37. Yep. And then you need to make sure that you highlight whatever the alternative hypothesis is, and in this case it is the second one. Press enter to highlight it, then go down to calculate, enter. So P is equal to 0.186. So I need to figure out, is P less than or greater than alpha? In this case P is definitely greater than alpha because alpha was 0.01. Okay, so because P is greater than alpha, we fail to reject. Remember I said if it's greater than, it's the one with more words, HO. Okay, now we just need to figure out how to word our final answer. So let's go up to the chart up here. So remember our claim was HA, we failed to reject. So is your claim HA? HO? No. Do you reject HO? No. So there is not enough evidence to support the claim. Okay. Not enough. To support the claim, and then we would just say that the mean delivery time is less than 30 minutes. Now you might also want to write in here somewhere like what the alpha was, what your claim was being tested at. It really just depends on what you're being asked to do. And I'm sorry, I keep accidentally hitting down here. Okay, so if we go back up to this is really important, and I definitely recommend you have some kind of screenshot of these flowcharts. But this is really important. Notice that this, whenever HO is the claim, notice whenever HO is the claim, God, I cannot write with this thing, then we're always talking about rejecting. Okay? So HO is the claim. Also notice whenever HA is claim, you're going to talk about supporting. Okay. Now also notice that the top ones on each of these is enough and then the bottom one is not enough. So if P is less than or equal to alpha, then you use enough. If P is greater than alpha, then you use not enough. Okay, so I don't know if I should just go ahead and do more colors here. P greater than alpha, you use the word enough. Or I'm sorry, P less than alpha. And then with, oops, wrong button. P greater than alpha, you use not enough. Okay, so it is a very systematic thing. I just like having this chart with me, but if you are working on this and you can't have a chart with you, it's important to remember less than alpha. P being less than alpha is going to make you say enough, and P greater than alpha makes you say not enough. If the claim is HO, then you talk about rejecting. If the claim is HA, then you talk about supporting. Okay, let's try the next one. A dietitian claims that the mean ice cream consumption by a person in the U.S. is at least 3.4 pounds per year. A random sample of 50 people in the U.S. shows that the mean ice cream consumption by a person is 3.3 pounds per year with a standard deviation of 0.95 pounds. At alpha equal to 0.05, can you reject the dietitian's claim? So the first thing I need to do is determine HO and HA. So this one says that the claim is at least 3.4 pounds. So we're saying the mean is at least 3.4 pounds, which means it's greater than or equal to 3.4. LBS. Now because it has an or equal to symbol in this, that means it must be HO. And HA would then be the opposite of it. So HA will have mu 3.4 LBS, but because this is greater than or equal to, this one will have to be less than. And don't forget to write that this is the claim. It's important because that's going to change how you word your final answer, whether you're talking about supporting or rejecting something. So now I need to figure out which test I'm going to use, and I'm going to do that by looking at my values. So N is 50. It says mean 3.4, so X bar. I'm sorry, 3.3. LBS, standard deviation, S is equal to 0.95 LBS. And lastly, alpha is equal to 0.05. Okay, so the question says, it doesn't say anywhere that it's normal. Okay, so the first question is it normal? No. Is N greater than or equal to 30? Yes, so we're going to use a z-test. Now, generally, if N is greater than or equal to 30, you're always going to use z-test, whether it's normal or not. So a lot of people will kind of skip this and just say, oh, well, I know is N is greater than or equal to 30. I'm just going to go ahead and use the z-test. So, z-test. Okay. So now I want to figure out what my P is going to be. So I do stat, go over to test, do z-test, stats 3.4, so this is whatever is in HO and HA. Sigma, I don't know sigma in this case, but I do know that it is approximately equal to S since n is greater than or equal to 30. So put that, and then 3.3, 50, and you want to make sure that you highlight the one that you're going to do, calculate. So I found that P is equal to 0.228. So in this case, P is greater than alpha. So that means I fail to reject HO. Okay, so since I failed to reject HO, that means, and HO was my claim, I am going to go up here and I'm going to say, okay, well, is HO the claim? Yes. Do I reject HO? No, there is not enough evidence to reject. Okay, and let's try the last one. The heights of 12-month-old baby boys is approximately normally distributed with a mean of 29.8 inches. A random sample of 15 12-month-old baby boys is collected and displayed in the following chart. At alpha equals 0.5, can it be concluded that the average height of baby boys differs from 29.8 inches? So the first thing I need to figure out is my claim. Okay, so claims that the mean is equal to 29.8 inches, so that's my HO. I know it's HO because it says it's equal to, and then HA will be the opposite of that, which is not equal to 29.8 inches. That's my claim. And now I need to figure out a few more things. The only other information given to me is that n is equal to 15 and alpha is equal to 0.05. Okay, so this is an example of when you select your test and you want to select data instead of stats. Okay, so the first thing I need to do is figure out which test I'm going to use. The first question is it normal? Yes. Do I know sigma? No. So I'm going to use a t-test. So, is it normal? Yes. Do I know sigma? No. T-test. Okay. So I go to stat, test, t-test, and I'm going to have to highlight data. But the only way this is going to work is if my data is in a stat list. Okay, so the first thing I'm going to do is hit stat, edit, and I want to make sure I put all of these values into my L1 column. So 25, 29, it's going to take me a little while. 33, 32, and I just realized that there was one up here. What is that supposed to be? 30.2. Okay. Why is it? Am I just like totally not 30.2? There we go. Okay. I can't type on this thing sometimes. Okay, 28, 32, So which one am I on? I'm number 10. So 27.3. Okay, and then 29.8. Okay, those all look pretty good. Okay, so I'm going to hit stat again, go back over to test, and I knew I was doing a t-test, so I pressed enter. So make sure that data is selected because I have all of my data in the first L1 column. Then mu naught is whatever value shows up in your hypotheses, so 29.8. Now list, this is asking what column your data is in. Well, we had it in L1, so we need to make sure it says L1. If you, for some reason, put it in L2, you would do second L2. Okay, I put it in L1 though, so I'm going to put it back on that. Frequency, if you did what I did, where you just put it all into one column, then you would leave this at 1. If for some reason you had a frequency distribution, however, and you put all of the values in L1 and their frequencies in L2, you would make this L2. But if you just put it all in one column, like this example, you make sure that says 1. Now I need to highlight the correct thing for the alternative hypothesis. We're looking at a not equal to. Then I go down to calculate. So P is equal to 0.164. So P is greater than alpha, so we fail to reject HO. Remember, HO was our claim. So remember, you could use this. Is HO the claim? Yes. Do you reject HO? No, we failed to. So there is not enough evidence to reject the claim. No, not weight. We're talking about height here. Okay, let me erase that. Boop. Wouldn't make sense to weigh 29 inches. Mean height is 29 inches. And that's it. The one thing that I recommend, like I said, is having these flowcharts handy. They'll really help. Remembering that HO and HA are always opposite of each other. And let's see. The other thing that's helpful is knowing when you need to highlight stat or data. Essentially, if it's a word problem, you highlight stat, and if you're given a bunch of data like this, it's probably going to be data. Okay.